we're doing it. I have no idea what we're doing.
Taking a test today.
We're taking-
I
I don't think it's today, but I know it's soon.
have a review today.
Turn to page 826. So I looked at this test just a little bit ago, and you might as well take it today because it's really easy. So here's the thing right now, think about this. Whether you want to write this down on your own right now or just think about them. You have to be able to tell the formulas for the area of these things. Are we ready? Chris doesn't have a pencil. Area of a parallelogram. What is it? BH. What kind of B? Little b. That's really important. Okay, that's really important for next chapter. How do I know what B and H are in a parallelogram? Yeah, it's the base and the height, but they have to form a what? Right angle. Exactly right. Area of a triangle. Okay, base times height divided by 2. Again, they have to have a right angle. Don't say this one out loud. Trapezoid. Everybody got it? Who's got it? Perfect. Base 1 plus base 2 divided by 2 times H. Rhombus and or kite. Formula.
Height, base 1, base 2.
D1 times D2 divided by 2. What is D1, D2? The diagonals, right? Everybody remember what a rhombus is? Rhombus is basically a square, right? But it doesn't have right angles. And then a kite has consecutive sides that are parallel. Area of a circle. No. What did we say on there? Oh, okay. What did you say? Pi r d. Pi r squared. Remember, you can use pi or 3.14. A sector of a circle.
The central angle of 360 times the area.
Right. X divided by 360 times pi r squared. And again, X is my central angle. The angle that's in the center of the circle. Regular polygon. Any regular polygon. First off, what's a regular polygon mean?
All the sides of it, all the angles add up to 360.
All the sides and all the angles are congruent to each other in whatever shape we're looking at. So what's my formula? Realistically, we came up with 2, right? 2 ways of doing it. One kind of used the formula and the other used triangles. So the formula was 1/2 capital PA, where capital P was my perimeter of my object, going all the way around the outside, and little a was what? My apothem. The apothem is what? The distance from the center to the side of my shape. It's not a radius, all right? How do I tell the difference between those two? A radius goes from the center to a point or a vertex of that shape. The apothem goes to the middle of that side. So what does the apothem do? It splits that central angle in half, but it also splits the side in half. Okay? The other way of doing those was basically finding the area of one of the triangles and then multiply by the number of sides. Essentially, it's the exact same thing. It's just thinking of it in a different way. And then the last thing was composite figures. So So that would be taking all of that stuff and doing them individually and then adding them together. Right? Those are the funky looking things. So you got to be able to do that on the test tomorrow. So from there, then we basically can just go through and look at problems. So in 11 through 14 on page 826, here they don't really go and show any of the ones that have the total. So if you have one of those that you want to look at, of course they don't even have it on the practice test. Oh, kind of. So 11 through 14 are pretty much the basic ones. They talk about the perimeter and the area. So make sure you read the directions and you answer the questions for what they're being asked. Perimeter obviously means the going around the outside of my shape and adding up all those sides. Okay, the area then is using those formulas. So any questions on 11 through 14? Good with those? 18 through 19, or sorry, 16 through 19. The first two are trapezoids. And then 18 and 19 would be your kites or rhombi. And 18, they honestly probably should put the little sides being equal, so you know that that's a rhombus. Or tell you that it is a rhombus, because they don't really do that. But any questions on any of those? See, I told you we could have taken it right away. 21 and 22 are our sector ones. Notice that they want you to find the shaded area. So when you find the shaded area, they give you the actual angles in this case, but you might have to subtract those angles from 360 degrees to get that middle angle. Like for instance, if they would have given you the white part of 22, then you would have taken 360 minus that white part to get your blue part, and then used it in that formula. Any questions with those? I know there's a few of you that had problems with that formula. So again, make sure you put the angle over 360 degrees. You can realistically multiply everything and then divide by 360 at the end if you want. That doesn't really matter when you divide. Okay with those? Then 25, 26, and 27 is our area of regular polygons. So do we need to do one of these? Yeah? All right, so now we got to decide which one you want to do. 25, 26, or 27? 27. So first off, in 27, what is my shape? It's a what? It's done it, isn't it?
Hexagon.
Hexagon. So what's a hexagon? Six-sided. So again, realistically, if you wanted to draw it, you can draw it. But the most important part is making this triangle, right? So we have a triangle like that. So if you're going to do the triangles, you're going to have to draw that triangle either way. If you're going to do the apothem, you're going to still have to draw that triangle. But essentially, we start out by figuring out what this angle is, right? And how do we find out that angle? 360 divided by the number of sides, in our case 6. So what do we get? 60 as the whole angle. And when we draw on this apothem, we divide that in half, so we get a 30. What other information in that problem did they give us? The apothem was how much? 5. So, what do we have to find in order to do this? If you want to use the formula, I need to find this, right? So essentially, I'm still going to break it into my little triangle, and I'm gonna find this little X right there. And so now, because this one's a special right triangle, anytime that I use a hexagon, I can use special right triangles. I have two options to do this, right? I can do 1, 2, square root of 3, or I can do SOHCAHTOA, right? If I do SOHCAHTOA, I'm starting at the 30 and I'm using those two sides. So what two sides would I use? I'd use tangent of 30, which is the opposite over the adjacent. Right? From the 30, we look opposite and adjacent. Remember, my hypotenuse is always the side that's opposite of my box. And so if you wanted to do this up here, then basically I'm taking 5 and I'm going back to 1. So I'm going to divide by the square root of 3. So either one of those should get you the exact same answer for that little x right there. And then with that answer, what do I do to that answer? I got to double it first, right? Got to double it to get the entire side, and then I'm going to take that times how much? 6, and that's my p, right? That's my p. Now, if you do the triangles way, you still basically have to do this entire process because you need base times height for that triangle way. And the triangle way is, just remember, I can make this triangle 1, 2, 3, 4, 5, 6 times. And that's the triangle. So if you like just to think of it as base times height divided by 2, it's the exact same thing with our formula. It's just maybe simpler terms, I guess you could say. All right? Do we need to finish this? That makes sense what we're doing there? So again, this one's a little easier. It's a little bit more intense, I guess. I don't know if intense is the right word. Complicated. If you don't know what was it, heptagon the other day?
Yeah, what was that?
7.
Oh my gosh, I think I put 9.
So, yeah, that was a big problem, not knowing what it was. Mm-hmm.
Wait, what's a 9 then?
Nonagon.
Oh, that makes more sense.
So you're close. Non-hep, they sound a lot alike. I'll get you those back here in just a second too. All right? Are we good with that?
Yeah, I.
Yes.
Some of it is important.
Okay, so before we get to the similar figures, anything with the composite ones? It would be basically 28 and then the one next to it. Going back to the quiz, anybody in here not take the quiz besides Cameron? I would show you the quiz, but then Cameron would get it right, and then you guys would all be mad. And you're going to get it right anyway? Because I don't think anybody got the perimeter of one of the things. Tell you the truth. So we'll kick him out at the end here, and we'll look at that. Okay? So, does anybody need any of those? 18 and 19 on the pre-test are okay problems. Any of those kind you want to see? All right, so then we go back to our figures, right? And the figures that are similar, okay? We're trying to figure out our scale factor. And the scale factor is the relationship that's happening. The biggest thing is make sure you read the directions. And in these directions, it says from the blue to the green. So if I'm going to do from the blue to the green, pick one of these. I don't care which one you want to do here.
32.
32. Sure, you pick the ginormous number ones. So 32 is 525 all over, what's that other number?
1,575.
Okay? But these are areas, right? So we need to make it into a scale factor that these are actually, because it's an area, they're going to be squared, right? So if they're squared, we have to unsquare them. So if you're using the areas, you have to take the square root. If you're using the scale factors, you basically have to square them to do the area part. So, what is a, does anybody have their calculator out? Is 525 a perfect square? I don't think it is. So, don't get frustrated if it's not a perfect square. What's a perfect square in one of these, or a perfect square number factor of both of those numbers? 25 to get you your 5. So what's 525 or $5.25 divided by 25 cents? How many quarters are in $5.25? 21. So we'd have 5 square root of 21 all over. How many quarters are in $15.75? Or what's 15? 63 of them. So this would be what? 5 times the square root of 63. Can I take the square root of 63? Not perfectly, but I can break 63 down to what? 9, 10, 7. Square root of 9. It goes to the outside, so we'd have 15 square root of 7. Essentially, then I can reduce my numbers on the outside. So here would be 1, here would be 3. And if you really wanted to do this to break it down more, you could say that I had 1 over 3, and then the square root, put all this in 1. The square root of 21 over 7, which is the square root of 3 over 3. And this is my scale factor then right there. Does everybody see what I did there? So basically, remember, I can take a radical over a radical. I can make it into one radical. That's what I did here. 21 over 7, I just made it into one radical. Then I just divided. So 21 divided by 7 is 3. And then radical 3 would have been on the top. And so this is my scale factor. I'm going to use that scale factor, and I'm going to then set it equal to what were my numbers in the problem? X over 18. Now, realistically, though, this isn't a fraction, or this isn't part of my scale factor. I'm just going to use this, and meaning I'm going to punch this into my calculator. Kenzie, punch the square root of 3 divided by 3 into your calculator. So if I'm going from the the blue one to the green one, am I going from smaller to bigger or bigger to smaller? Smaller to bigger. So if I'm going from smaller to bigger, I'm getting what? I'm getting bigger, right? I'm going from the smaller one to the bigger one, I'm getting bigger. So I'm going to multiply 18 by this number right here. What was the square root of 3 over 3?
I don't think mine's right. I don't think I'm doing it right.
Take, you probably have to take 3, get square root of 3.
That's what I did. 3.
Square root divided by 3
Yeah.
equals. Now take that times 18.
10.39.
10.39. Exactly right. Okay? So, that one's a little weird just because of the fractions. If you want to do another one, we can do another one. Let's try 31. In 31, if we go blue to green, we would do what? 8 over 32. Okay? In this right here, the first thing that I'm going to do is reduce my fraction. So I'm going to cut it down to 1/4. And then if I have 1/4, I'm going to now take the square root of both of these because this is still an area, right? These were areas. So I'm going to take the square root of that. What's the square root of 1? What's the square root of 4? 2. I'm going to use 1/2 in my fraction. And what were the pieces that they gave me in that one?
4 over X.
4 over x. So what's my answer? 8, right? So that one's a little easier to see, hopefully. But do you see what we did there again? So if it's the areas, I can reduce, and then I take the square root of them. So we could have just reduced this one first and then took the square root. We kind of did that all at one time. This one is just a little bit more complicated. But basically, I'm taking this number. If I'm going bigger, I'm going to multiply by the number that they give me. If they're going smaller, I'm going to divide by the number that they give me. Okay? That make a little bit more sense with those kind of problems? We can do 32 if you want. You want to do 30 also? No? Okay. So, any questions other than that in general? We'll get the quiz back so we can look at the quiz and ask any questions on the quiz. Like I said, I think the one perimeter problem did give everybody a little trouble, so we can look at that one.